Hey everybody. So in this video, we're going to look at problem solving with Pythagoras' theorem. We'll work through 3 examples, and if you want to work along with me, you can download this PDF from my website. So if we look at example 1, we need to work out the length of x. The problem is we haven't been given either of the two other sides in this right-angled triangle, but we have been told that the two sides are the same. So what we need to do is we need to use this right-angled triangle, BAD, to find the length A to B. Once we have this length, we know it is equal to this one. And then we can apply Pythagoras' theorem to work out x. So if we look at this purple triangle, if we call the length A to B h, then we know using Pythagoras' theorem, the area of a square on the A to D plus the area of a square on A to B will give us the area of a square on the hypotenuse side. So we can write this as 3 squared, which is the area here, plus the h squared, which is the area on this side, will give us the 5 squared, the area of a square on the hypotenuse side. So h squared will be 5 squared, 25, minus the 3 squared. So h squared will be equal to 16. And then we can take the square root of both sides, so h will equal 4. And I'll include this on the diagram here. And because it's isosceles, we know A to C will be the same. So now we can look at the green right-angled triangle. We can work out the hypotenuse, x, using the same idea. The area of a square on this side plus the area of a square on this side will give us the area of a square on the hypotenuse side. So 4 squared plus the 4 squared will equal x squared. Well, 4 squared plus 4 squared is 2 lots of 16, so 32 will equal x squared. So x will be the square root of 32. We can work this out and we get approximately 5.66 centimeters to 2 decimal places. Okay? So it's all about identifying which right-angled triangle to use, and that will give us a clue for the next step. If we look at example 2. So in example 2, we've got a different type of question. It's still a right-angled triangle, so we'll use Pythagoras' theorem, but now we need to set up an equation involving x, and then solve that to work out its value. So if we look at the area of a square on the side of the 8 centimeters, this will be 8 squared. And if we add it to the area of a square on this side, then this will be x minus 2 squared. And what do you think this will be equal to? Yeah, so this will be equal to the area of a square on the hypotenuse side, which is x squared. So now we have our equation, we can expand out this x minus 2 squared. So we'll have the 8 squared, which is 64, plus x minus 2 multiplied by itself. What do you think we should do next? So now we're going to expand out these brackets. So we'll have the 64 plus the x squared, and then minus 2x minus another 2x plus the 4, 2 times 2. And this will equal x squared. We can simplify these terms, and we can add the 64 and the 4 together. So we get 68 plus the x squared minus the 4x will equal x squared. What do you think we need to do now? Well, we can simplify this further by taking away x squared from both sides. And these will cancel to make 0. So we get 68 minus the 4x will equal 0. And then we can move a negative 4x to the right-hand side. So 68 will equal 4x. Then we can divide both sides by the 4. So x will equal 17. Okay? And this will be the length of the hypotenuse, 17, and the vertical height will be 15. Okay? Let's try one more question. So in example 3, we've been given a semicircle joined to the edge of a right angle triangle, and we need to work out the area of a total shaded shape, given our answers to 3 significant figures. So perhaps you want to give this question a go yourself. You can pause the video and come back when you're ready. Okay, so how did you get on? Well, the way I'm going to go about this is I'm going to break it up into 2 shapes. The semicircle and the right angle triangle, which I'm highlighting in blue. So all we need to do is to work out the area of this semicircle, work out the area of a triangle, and then add the 2 together. We know the area of a triangle is 1/2 of a base times the height, and the area of a semicircle will be 1/2 of pi r squared. Pi r squared is the area of a full circle, and then we just divide it by 2. So we need to work out the radius for our semicircle, which is this length here. And we need to work out the perpendicular height for our triangle. But you can see that this height is 2 lots of a radius. So all we really need to do is to work out this height. Then we can divide it by 2 to give us the radius of a semicircle. And we can work out the height of a triangle using Pythagoras Theorem. We know the hypotenuse is 18 and the base is 16. So the height will be the square root of the 18 squared minus the 16 squared. And this gives us a height of 8.25, or approximately 8.25 centimeters. So we can work out the area of our triangle as 1/2 of the base multiplied by 8.25. And when we work this out, we get 66 centimeters squared. So then for our semicircle, well, if the height is 8.25, we can divide that by 2 and we get the radius. So the area of our semicircle will be pi times 4.125 squared, the radius squared, divided by 2. And this works out as 26.73. So the total area will be the 26.73 plus the 66. And this gives us 92.73 centimeters squared. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.